Okay, hello and welcome back to today's session. So this has been the 5D session. Today's the grand finale. Today is when we're going to look at how we're going to be building a subsection of an application that makes use of all of the different services that you have been using and looking at over this week. So thank you again so much for joining us. Before I get started, is my screen visible and am I audible? If I could just have a quick thumbs up in the chat, that would be awesome. Just to let me know if my screen is visible and if I'm audible, that would be great. Yep, awesome. Thank you. All right. Okay, so we'll get started. So let's kind of like do a bit of a recap. So this week has been an introduction to AWS Cloud and some AI tools and AI services on the AWS platform designed specifically for beginners and for folks who are looking to build a career in cloud computing and maybe even AI technologies. Now, you may already be working in IT, but you may wish to move into cloud and AI space. And so hopefully this week has been instrumental in helping you grasp some of the complexities around the different technologies that you have to contend with in order to build applications or engineer solutions for your clients, be that, whatever the client is and whatever role you take. So as a cloud engineer, a cloud architect, an AI engineer, AI architect, DevOps engineer, whatever it is that you're interested in. We've spent a bit of time this week looking at some fundamental core AWS services to help you embark on your journey. And so hopefully by the end of today, we're going to be taking a look at a demonstration about how we'll construct and use these various services that we've learned over the last few days to get you in a position to see how those services are being used to build an application. Obviously, we're not going to build a complete production-grade application purely because there's so many moving parts, but we're going to focus on the backend processes of an application that actually uses AI tools and machine learning tools to drive it. Okay, so hopefully that's going to be a little bit exciting as well. And when you take a look at some of the things that are available out there, some of the services that are available, in terms of setting up or using AI tools and services, it's always a wonder what's actually happening in the back end and how we would, as engineers, go out and build something similar for our clients and our customers. So this becomes really important in understanding the nuts and bolts of the core infrastructure services that you're going to be using to build solutions. So today is day 5. Thank you again for joining. I really appreciate it. I know you're obviously, contributing your time and, investing your time in it. So I'm hoping that this is going to be a nice icing on the cake and a nice end to the week. Okay, so let's proceed. So today, obviously, so far we've covered day 1, day 2, day 3, and day 4. So we had a look at what is cloud computing, what is IAM, introduced you to S3 and CloudFront, compute services on the AWS platform like EC2, Lambda, ECS. And also we looked at some services to decouple different components of your application stack. And I mentioned on day 3, this is really critical because front-end and back-end services tend to scale differently based on load and traffic. So you may get a lot of traffic coming in on the front end, but the back end isn't able to necessarily keep up. So we spoke about things like decoupling solutions using SQS queuing systems and SNS notifications. And then yesterday, we had an introduction to machine learning, a cool introduction to Gen AI and some of the concepts around what makes Gen AI possible. But then we also proceeded to look at some of the services on the AWS platform that you can actually use to build Gen AI solutions. Okay, so today we're going to do a bit of hands-on demonstration and actually look at how we can use the various services we've been working with or being introduced to chain together a solution for us. Okay, so I'm going back to the original concept that we spoke about. There's this wonderful AI tool called Lovable that allows you to basically provide a prompt and you can generate a web application. And specifically what I was focusing on was building a web application or a website, if you will, that can host your resume so that instead of sending your resume as a PDF document or a Word document to recruiters and hiring managers, you could have it like a link on your LinkedIn, right? And you can use that to actually allow people to see your resume instantly. And if it's a website, it can be constructed in a way that's intuitive, easy to navigate, and it's got all the bits and pieces of information there. And obviously, you can use your styling methodology that you want in order to make it look awesome as well. Okay, showcasing your skill sets, but also being aesthetically pleasing. So we had a look at Lovable, and one of the things that Lovable does is it allows you to provide it with some content. Okay, so we spoke yesterday about AI tools enabling you to provide it with a prompt and supply it with some data. So here we supplied it with a resume.pdf document, okay, for a chap called Jason Coffey. Apologies for the lack of imagination on the surname. But essentially, what happens there is Lovable will take that data, extract it for you, and then generate the website for you. And because the prompt was really simple, we kind of left it to Lovable to decide exactly how the website should look, which is fine. We can obviously be more assertive and specify exactly how we want the site to look. We might specify some color codes, some accent colors, some layout information, and all of that can go ahead and build us a website or a resume website that we can then publish. But one of the things that AI has or struggles with on its own, especially these AI tools, is the fact that it uses probability, statistical elements, and math to generate all of the necessary content that it's generating. So that means that you may not get exactly the thing that you're looking for, okay? Or if you try and build that same solution again, the output might be slightly different, what we call non-deterministic in the industry. So regardless of how fantastic AI is, you still need to consider, using various types of solutions and traditional approaches to ensure that you add these guardrails or these boundaries in the way how things are delivered and constructed and presented to an audience. And this is particularly important for certain industries, take banking, insurance, that kind of thing. Okay, so we'll move on then and take a look at the requirements for the for this particular use case. So we've got our users, and we want to build a solution where the user can upload a resume, they can select a design pattern. The application will extract the data from the resume. So this could be a Word document, a text file, a PDF document. And then using the data that's in there, it needs to understand what that data is and then generate an HTML or any kind of web application or website, HTML, CSS, JavaScript, etc. And so that it makes it presentable. And then the output should be a website that is published, accessible to everyone on the internet. You get a URL, and then you can send it off to recruiters, hiring managers, and also obviously, put it on things like your LinkedIn and your business card or whatever it is you want to do. Okay, so that's the whole idea behind today's use case and our anticipated game plan. So here's a quick question for you. And I'd love it if you just, contribute in the chat as well for this. The workflow, let's just take a look at the workflow again. So we want to upload our resume. We want to be able to select a design pattern. And some of this stuff we won't be able to do live, obviously, but I'll explain as we go along. So we want to select a design pattern. We want the application to extract our data from the resume, create a website, and then publish it in a manner that is hosted and available on the internet, and ideally with low latency and accessible to on a global scale. Would you like to suggest, therefore, which of these services you are likely to use in order to help you build that solution? And I'd love some feedback in the chat for this, because that would be awesome for some engagement. Any suggestions? What would you use to upload your resume? What service you might use to extract the data? What about things like creating that HTML website? What services would you use, given the fact that some of you have been on this journey with me since Monday? Any suggestions? Okay. Lasagna, textract, yeah, absolutely. So textract can be used to extract the data from the resume. Brilliant. Thank you for that. Vinayak, S3, textract, CloudFront, and IAM. Yeah, okay, good. So you would use S3 for storing your resume, Vinayak? What would you use S3 for? Textract obviously is going to extract the data. Wonderful. What about S3? Yeah, okay, for storing the actual resume. And then you mentioned IAM, so that's really good because obviously when we have different services talking to each other, remember we spoke about this on Monday, um, you need permissions, you need authorization. So if you're going to get Textract to pull data from S3 that's holding the resume, you must allow Textract to be able to talk to S3, and therefore you need to give it permissions. And one of the ways of doing that is using IAM, more specifically IAM roles. Okay, good. Thank you. Anything else? Anyone else? What about actually creating the website? Any services that we've touched on or spoken about this week you think you can use to actually generate that HTML code? Any suggestions there for that one? So Vinayak, you also mentioned CloudFront. So CloudFront is a distribution point, so that's good. But what about actually generating the website? What could we use from any of these services? Amazon Bedrock. Okay, yeah, we could use Amazon Bedrock. Yeah, we definitely could. S3 or EC2. Okay, so that's good. So we can use S3. Okay, so we can use S3 to host the website. We need some sort of compute service to actually generate the HTML code. So potentially we could use EC2 for that. We could have a Python script that can actually generate the HTML or that can be configured with HTML information or script so that we have a particular framework within which to place our resume data into. Okay, S3 would just be used in this instance to host the website. It wouldn't necessarily help you to actually generate or use that HTML code in any way. But we can certainly use compute services, so we can use EC2 for that. Okay, great. Um, so Bedrock, yep. Okay, S3 and EC2, yep. Thank you. All right, fantastic. Okay, so let's proceed. So we've got all different sets of services here. We've got S3. So just a quick recap before we move on. S3, great for storing data, and also you can use it for hosting your website. That's made accessible globally. Add CloudFront in front of it, and CloudFront allows you to add a lot of the security components to it, but also distribute your content globally, okay, and make it accessible on low latency networks. Because if you remember from day one, CloudFront makes use of edge locations. Everyone's mentioned textract. So textract is absolutely brilliant. It can extract the data from PDF, Word, scan documents. It can even read handwritten text as well. So it's absolutely brilliant to extract data. And then we can obviously use IAM for all of the permissioning that needs to be in place so that these services talk to one another. Now, EC2 and Lambda or even ECS offer compute services. And these compute services can be used to essentially create that website, for instance, okay, or talk to services like Textract or Bedrock to instruct it to do something. Okay, so if we're going to tell Textract to convert a PDF document to a raw format that it can read, we need some sort of compute process. We need some way to trigger it. So we can use a piece of code to get the data from S3 into Textract or tell Textract where the data is. And we can use Lambda, we can use EC2, we can use ECS. And obviously, based on the use case, based on exactly what it is you're trying to do, one of those compute services is obviously going to be better, cheaper, and more efficient than the other. Okay, and we spoke about this on Wednesday as well. Okay, and then decoupling your architecture becomes important because when you upload your PDF document to S3, something needs to happen, right? A piece of code needs to actually read that data and then maybe give it to Textract. So we could use something in between to help it do that. And when Textract has extracted the data, well, then what? Then we need something else to actually pull that data and build out our website. So we might have an EC2 instance, an ECS container, or even a Lambda function to help us with that. But how does Textract talk to one of these compute services? We can send out a notification. We can send out a notification using SNS, for example. Okay, so a lot of these services are going to be consumed today. Another service here is CloudWatch. Now, I briefly mentioned CloudWatch on Wednesday. And essentially, this is absolutely, something you really need to learn if you want to become a cloud engineer or a, solutions architect or any kind of engineering work you do on or in the cloud. Using CloudWatch will help you monitor what is going on. It will allow you to see log files, do debugging, trace the way how the application is functioning, and it becomes really important to get some hands-on experience there as well. Bedrock, I haven't mentioned that yet. That's going to be really, really important. Bedrock is something that we're going to be using today, but not necessarily in the way you had anticipated. And I'll explain more as we go along. So will we be learning EKS and Fargate? Not in today's session, unfortunately, but obviously my AWS Accelerator program covers that in depth. So yeah, we won't be touching EKS today or ECS Fargate. Instead, we're going to be using one of the other compute services. So yeah. Okay, so let's move on then. So the resume website, the technology, various technologies that we can use there for. We can use, like I said, S3 to host the raw upload. So when Jason Coffey decides to upload his PDF document, we can host it in an S3 bucket. And we spoke about something called event notification. Okay, when something happens in your S3 bucket, whether you create a file, whether you delete a file, you create a new bucket, you create some folders, those are all events. And so we can use that as a way of enabling our application lifecycle. Okay, enabling our application to, to do something next. So this whole concept of event-driven architectures becomes really, really fantastic because we don't need to have idle compute time just sitting around doing nothing, right? Instead, when we upload the resume into the S3 bucket, we can trigger some compute service to react to that in some way. We can send a notification out to someone. We can send some message into a queue so that something else can pull that message. We can react to it in some way. And so here we can trigger a backend processing task to go and do something with that resume.pdf document, right? So that becomes really, really great. And it helps us, sort of manage that in a more efficient way. Okay, so next, what we could be doing, okay, and we can also use another product called Lambda. So Lambda is a compute service. It's a serverless compute service that allows us to obviously be in a position to, see exactly or run any kind of compute service against things that have happened. So here the user is uploading the PDF document to S3 bucket. We can use event notification to trigger a Lambda function so that that Lambda function can run a piece of code to instruct Textract to extract the data from the from the PDF document. Okay, so we can have Lambda respond to that event notification, instruct Textract to actually go ahead and extract the contents from the resume. So it can send out an API call to Textract. And then subsequently, when Textract has done its extraction, it can build a resume with HTML, CSS, and JavaScript code. Okay. So the whole idea behind this is that we need some compute services in the middle to allow the different components of the application to work with each other. Next, we have obviously Textract. So we've been talking about Textract a lot today. So it's an AI service for extracting text and data of scanned documents. It detects both type and handwritten text, and it goes beyond OCR by understanding document structure. Okay, now here's the thing. When Textract extracts the data, if you get Textract to extract any kind of data, you need to be able to understand that data. Okay, so Textract can look at a PDF document, and obviously using some APIs and some inbuilt, templating, it can actually also do a lot of stuff like understand expense reports and stuff like that, or layouts and stuff. But when you have a custom application like say a resume, you must understand that obviously everyone's going to build their resume slightly different, right? It's not going to be exactly the same. Anyone who, if you're building this application for real world use case, anyone who's going to upload their resume, you may restrict them to upload it in a specific format. So you may say, we will only accept PDF documents or Word documents or something like that. But at the end of the day, the structure, the layout, and maybe some of the headings might be different. So if you extract the PDF document using text writing, then just give it to Lambda, and Lambda goes and builds the HTML code and presents it in an HTML format. The problem there is you may encounter situations where the build is going to be any good, okay, especially if you're not using AI, because the extraction is going to look something like this. It's just going to be, line by line of all of the data that's been extracted. So Jason Coffey, his summary, he's an engineer, his professional summary, all of his experiences, then maybe a list of skills, and it'll just go through that entire document. And that document might be 1 page or 5 pages, whatever it is. And it's going to be in a position where it's just got the raw data and it's just giving it to Lambda. Now, Lambda needs to figure things out. Is Jason Coffey a name, or is coffee a coffee? Is this a section heading? Professional summary. Is AWS a skill? Is EC2 how does Lambda know what these words actually mean, right? On its own, it's not capable of doing that. So we end up with a situation is that if you don't use AI in this scenario, you've got to do a lot of parsing rules in your Lambda, in your Python code. And it's going to make your Python code really complex, really messy, and quite crazy to handle. Okay, so you're going to say if professional summary in line, else if then statements, and you might have some arrays and loops and all of those things, but it will just be quite cumbersome to handle just with pure Python running in your Lambda execution environment. Okay, so this is something you need to consider. And so here, what we can do instead is we can bring Bedrock into the picture. Okay, so Bedrock allows you to access foundation models and large language models, and they allow you to do things like generate data, but they also can, do things like classify data. And they can understand what the data is. They can identify if it's a name, if it's a heading, if it's a skill, because it's got all of that training stuff, training material that it's been given, the vast amounts of data that it has been trained upon. It's able to decipher and identify what your resume actually means. And we spoke about this yesterday at great length. We talked about, things like embeddings and vectors and working out, using self-attention and transformation in order to work out what those individual pieces of text are, right? So it understands context of extracted data. And so what we can do is instead, we can have Bedrock read through that data, understand what it is, and then deliver that data to a piece of Python code in a format that the Lambda function or the Python code can actually consume it. So something like a JSON format. Okay, so here we're using Bedrock. Okay, so Lambda is going to instruct Bedrock to classify the content and format it correctly in a JSON format. And then we end up getting this JSON breakdown with headings and using key value pairs to basically identify what those pieces of data actually mean. Now it's a lot easier for Lambda to go ahead and build that HTML document and then subsequently be in a position to build that website. And furthermore, what you can actually do here is you can have like a selection of different templates types to choose from based on what the user wants. So we're only going to be looking at the backend processing today, but the front-end element of it, and I'll speak more about this in a second, the front-end element of it can allow the user to select, okay, I want to build my resume website, I want a dark mode, I want these colors, and this is the template I would like to use. So immediately you're going to make sure that the output that takes place is going to be, consistent, it's going to be reliable, it's going to be exactly what the customer wanted, and you have a deterministic output there. Okay, so these are some important concepts to bear in mind when you're thinking about building your application stack. We could very simply just extract the data, send it to Lambda. Lambda can put it into an HTML, but it get very confusing and very messy. Or we can start using AI to help us build a more sophisticated application. Okay, so next, let's go and take a look at what we're actually going to build today. And we're going to use the application from where we started off on Tuesday. So on Tuesday, we just built this S3 bucket. We put a CloudFront distribution point in front of it, and we had a very basic, plain, simple looking resume website. So Jason, our guinea pig, is going to upload his PDF document into an Amazon S3 bucket. We're going to use event notification. In fact, we're going to trigger a Lambda function because an event would have taken place. When he uploads that PDF document, that's a create event, okay? A create object event or an object create event. And that is going to trigger the Lambda function to process it, to look at it, okay? So it's going to actually see what that is. And if it is in the PDF format, so we're going to restrict it to just PDF documents rather than Word or some sort of XLS or some sort of other formats. That's going to go ahead and tell Textract, hey, Mr. Textract, there's a new document in the Amazon S3 bucket. Here's the file that you need to extract. Okay, so Textract is then going to be able to see that file and then pull it across, and it's going to complete the extraction. When it completes the extraction, it needs to then do something. So we're going to use SNS so that I can send out a notification to say, hey, I've completed the extraction. Here's the data. And we can then use another Lambda function to be triggered by that notification. So remember with SNS, that's a publisher subscriber model. You can send out notifications to not just email and SMS, but to other services like Lambda, HTTPS endpoints, and so on and so forth. Here we are using SNS to trigger yet another Lambda function that's going to process that extracted data. And in fact, what it's going to do is it's going to retrieve that extracted data from Textract, because now Textract has done the extraction, send it across to Bedrock, tell Bedrock, hey, listen, I need this in a format that I can understand. So we're talking about that JSON format. And then be in a position to go ahead and process that JSON file and build out that HTML output. Okay. Next, it's going to then go ahead and deposit that into the S3 bucket, into the user who initiated the request. Okay. So in this case, I'm just going to call it user 1, and then supply the generated index.html file into the S3 bucket. In amongst all of these different workings, obviously we're going to need IAM roles so that all of these different services can talk to each other. And to ensure that we can track exactly what's going on, we're also going to be taking a look at CloudWatch, and specifically CloudWatch logs to sort of monitor exactly what's going on here as well. Okay, so hopefully this is this is basically the architecture design pattern and the plan. And obviously this represents the backend processing of your data. Remember, today we're not looking at the front end. And the front end could also be built to complete the application stack and then to build something viable that could be tested, tried out, and released into production. When Jason comes to actually access his website, he's going to be going via CloudFront, and then he can supply the CloudFront distribution URL, which incidentally can also be associated with a custom domain name to recruiters, hiring managers, put it up on his LinkedIn profile, so on and so forth. So you can create separate upload folders as well in the S3 bucket, which is something we will do, so that the user can basically select which design pattern you want. So I spoke about this a little bit earlier, where you can configure the front end so that it says, okay, you can select a dark mode or a modern or a minimalistic design pattern. So we're going to simulate that by creating those separate folders, and it's going to use that folder to determine exactly what style we're going to build when we actually process that output as an HTML document. In production environments, you will also build front-end interfaces, like I said. So you'll have a front-end UI with a sign up and a sign in to the web application to enforce security. You will use services like Amazon Cognito, API Gateway will often be used for these other features. Again, these are technologies that you would use when you're building the complete end-to-end solution, okay? And you want to release that in something that is production grade out to basically market and sell to your customers. Okay, so the infrastructure so far looks like this, right? We've got currently the S3 bucket with a folder called website in it, with the index.html page in it. This is what we did on Tuesday, and it's backed by a CloudFront distribution point so that we can distribute that content globally. Okay, what I'm going to do is I'm going to just stop the share and go. We're going to jump into the AWS Management Console. Okay. If there are any questions in the meantime, feel free to drop them into the Q&A. Let me just bring up the AWS Management Console. Okay, I'm just sharing the AWS Management Console so we can see this live in action and see how it works, okay? Right, give me a second. Okay, that should be fine. All right, let's do a quick recap. So if we take a look at, so this is my, obviously, AWS Management Console. I'm using the United States North Virginia region. And if I go into my CloudFront distribution, that was the distribution we created earlier. So if I open up a browser tab and just type that in there, and it's website index.html, that was what we created on Tuesday. A very simple, plain looking, non-exciting website, right? And it's a viable URL. You can just distribute that if you want it, or we'll go ahead and build our solution next. Okay, what I want to do is I want to take you step by step through the process of how we're building this, how it actually works under the hood, rather than just do the final deployment, because I think it will be, quite beneficial to you in seeing how this thing actually functions. So I'm going to go through different phases. We're going to start with something called phase one. In phase one, what I want to achieve is basically get to a position where, we can see how the Lambda function starts to work. Okay, so I'm going to open up. So let's just bring this here. I'm going to open up Amazon S3 in another tab. Just make it a lot easier across tabs. And I'm going to go to that actual bucket that contains the actual website. Okay, so Rajesh resume website. That's the one over there. And that's the website folder. That's the index.html page that we're looking at in that distribution point over there, just there. Okay, so we're going to go ahead and I'm going to create those folders, those design folders. And again, this is something that can be automated. I'm manually creating right now, but if in the front end, the user logs and signs up for this application and decides to create decides to create his resume website and select any pattern, any design pattern, those individual folders can be automatically created for him or her. Okay, so here what I'm going to do is basically create those folder structure first. So I'm going to create a folder called uploads so that the data gets uploaded to this uploads folder. Okay, so uploads. And in uploads, I'm going to create the 3 design subfolders. So I'm using 3 at the moment. So modern, minimal, and dark. So create one called modern. Okay. And so that's fine. And yep. And then we'll have, uploads and create another folder. And this one is called minimal. Okay. And these naming conventions are really important because Lambda, the code that we have, is going to actually make use of this. So it's going to see that if the file is in this minimal folder, that it's going to give you the minimal design pattern. Okay. and dark. So you need to make sure you get this spelling correct as well. Okay. And in each of these subfolders, I'm going to add another folder, user1. Okay. So user1. And again, this would automatically be created when a new user signs up to your application. Okay. And that can be all scripted out. So whereas I'm manually doing it over here, because we're not working on the front end, we can automate this entirely. So it's not an issue at all. So minimal, and then user1. And then if I go to uploads again and go to, did I do dark already? Yeah, I did. So I go to modern and we'll create a folder there. And I'll call this one user1 as well. Okay. Right. So we've got the resume website. The actual website, when it's generated, is going to be stored in this folder, okay, and accessible on the internet via the CloudFront distribution. The uploads folder is literally private. It's used only for users who would authenticate and be authorized to upload their PDF documents. And obviously, when you look at something like Dark, you will see here we've got user1. So the code that manages the front end is going to ensure that user1 only has access to the user1 folder in the dark subfolder, right? In the dark top level folder. In other words, we can ensure using IAM permissions and policies that one user can't access someone else's resume, okay? So all of those security protocols and measures need to go in place, and that's going to be part of your design pattern when you're building this out for real world use case. Okay. So the next thing that we want to do is obviously we've got our folder structure created, right? And we can then proceed to actually build out the Lambda function. Okay, so what I'm going to do first is I'm going to show you how Lambda is going to recognize that there is a file in S3. Okay, so I'm going to go into Lambda. So as I said, we're doing this in phases. What we want to do in this phase is just see how Lambda actually picks up on the fact that, oh, there is a resume.pdf document in the folder, okay? And we'll go into Lambda. So Lambda allows you to create functions. So you can create a function. And I've got all of the codes, obviously, for you in our GitHub repository, so you can try this out in your own AWS account as well. Okay, so we create a function. This function is going to be called resume processor, okay? So we're going to author our own function from scratch, right? And the function is built in Python. Okay, so we're going to use Python for this. It's going to create a default IAM role, okay, which allows it to send log information to CloudWatch. And I'll create the function. Okay. Just wait for it to create the actual function. Okay, so that's the function created, but obviously I still need to provide it with the code. So give me 1 second. I'll show you the code as well. Okay, so this is the code. Okay, it's a simple code. All it's saying is that I've received an event, okay, from S3, and Lambda was triggered successfully. So when we upload that PDF document to S3, we just want to see how this works, that it's able to trigger that Lambda event. Okay, so it's a fairly simple 10-line code. Okay, so here I'm going to go and basically upload this code. Let's get rid of that. Okay, so this is just some boilerplate code. We can get rid of that, and I'm going to paste that in there. So this is the code. All it's doing is it's going to realize that it's going to be informed that there's a new file uploaded to the S3 bucket, and all you need to do is then deploy that. Okay. A couple of things that I'm also going to do, and this is something you need to look at from Lambda's perspective, is that how long do you expect Lambda? How much time do you expect Lambda needs in order to execute code or do some processing? There's a configuration option here, and the default timeout is set to 3 seconds. That might be too short. So I'm just going to increase that to 30 seconds to give it sufficient time to pick up on the fact that there is a new file in the S3 bucket. In fact, 3 seconds will probably do it, but just for safety's sake, I'm increasing it to 30 seconds. Okay. Right. So the code is in Lambda, right? And all it's going to do is identify the fact that, this resume.pdf document has been uploaded to that S3 bucket that we're interested in, right? And it's successfully deployed. At this point, it doesn't know about S3. It doesn't know that S3 even exists, like that bucket even exists. So we need to add a trigger. Okay. So we're going to add a trigger, and the trigger is going to be S3. Right? And specifically, the bucket that we're interested in is the Rajesh resume site. And you'll see it says that it's going to monitor all object create events. In other words, when you upload something to an S3 bucket, that is called an object creation event. Okay, so it's going to look at that. The other thing that we need to do, and this is something we need to be careful about, is we're actually going to only monitor files that are uploaded to uploads and anything in uploads. Okay, so if you think about this visually and just try and visualize how this works, you're uploading a file to the uploads folder. Lambda is getting triggered to do something. And then Lambda, later on, the second Lambda is going to generate this HTML file and put it in the website folder. So we've got 2 folders in S3. We got the uploads folder and we got the website folder. Now, if we were monitoring just the root of that S3 bucket, we'd end up going in a loop, because every time Lambda generated the HTML file, this first Lambda function will get triggered again. Okay, and we don't want that happening, right? So there is this recursive invocation where it's giving you that warning that if you don't set this up correctly, you could end up in an endless loop. So we're just going to tick that. We understand what that is, which is why we're putting this in place. We're only going to monitor what's uploaded to the uploads folder. Okay, so then that is in place. I'm just going to check that I'm looking at the right bucket and object create events, uploads slash, and I acknowledge, and then I'll click add. Okay, so now we are in a position where the resume site was successfully added. So the trigger was successfully added. So it's now looking at anything that happens to that S3 bucket. Okay, and just to see again the code. So the code is there. Okay, cool. Just down a bit. Yeah. Okay. And it shouldn't need, there's no changes, so no deployment changes. Okay, fine. So at this point, what we can do is we should be able to upload some data to S3. So I'm going to go over and click on the resume site, click on uploads, I'm going to go and click on doc, and in user, I'm going to upload one of the actual resume. So just give me a second. So click upload, and then I am uploading this file, the resume.pdf, and I'll click upload. Okay, so at this stage, we've successfully uploaded the file to the S3 bucket. This time we're uploading it to the dark mode. Okay, so this is something that a subsequent Lambda function will handle. But essentially, this is the folder. We uploaded to uploads, dark, user1. So it's in the user1 folder. And so what needs to happen, or what should have happened, was Lambda should have been triggered because of that trigger that's in place. Okay, so we can go into something like CloudWatch. And just give me a second. Okay, and go to something like CloudWatch. And we looked at CloudWatch really briefly before, but there is CloudWatch is a really powerful tool. You will have to learn this quite well. There's the log management section. Okay, and what you can see is there is a log group called resume processor. This was generated literally just now because we initiated and initialized our Lambda functions. If I go into this, I'll see that there is a log stream. and the log stream actually captured that information. So if we take a look at what actually happened, okay, here you can see that it received an event. The event was an object create put event, okay? It was from this IP address. It was uploaded to that bucket because that's the bucket that it's monitoring, obviously. And in fact, it even tells you where that file was uploaded to. Okay, so uploads dark user one, PDF one, okay, and so on. So we know now that Lambda can be triggered by that update, by that object create event. So that's phase one, just highlighting the fact, just showcasing to you how we can get one resource of a service talking to another resource of another service. Okay, so we'll move on. We can obviously see that that bit of it has worked. So I'll move on to phase three. Okay, now in phase three, what we want to do is we want to start using Textract. So we want to hand over this PDF document to Textract to tell Textract, hey, go ahead and extract the data from it. Okay, so remember in our architecture diagram, right? Let's just bring that up for a second. In our architecture diagram, Textract, once it extracts the data, is going to send a notification out to SNS. So we need to create that SNS notification topic first. Okay, so I'm going to go into SNS. Okay, and we'll look at topics. And I'm going to create a simple topic. So a topic is basically an access point where a publisher can send a notification. It goes into that topic, and then whoever subscribes to it, that message gets pushed out to the subscribers. So in this case, Textract is going to send that notification, okay, to say job complete, I've extracted the data, and a backend Lambda function that's now going to actually do the hard work is going to receive that notification and be triggered by it. Okay, so here I'm going to go ahead and create that topic, standard. And there are different types. There's FIFO and the standard. We talk a lot about this in the course, obviously. So FIFO is first in, first out, where you actually need the ordering of the messages to be strictly preserved. Standard is generally what you use otherwise. But I'll create a topic named Textract complete, and I'll just also put that in the display name. And there are several parameters as well that you can, configure: encryption, access policies, message delivery status, and it's a deep dive in itself. Obviously, we're not going to cover that today, but that's something that you can definitely look at and would need to, consider some of those options when you're working in real world use cases. Okay, so I'll create the topic. And for me, the most important thing for the purposes of this demo is this Amazon resource name. Remember, I spoke about this earlier. Every object, every resource, every user you create, every IP address you create has an Amazon resource name. It uniquely identifies that resource so that you can reference it from other parts of the application. Okay, so we're going to be using this ARN shortly so that we know exactly which topic we're sending our messages to. Okay, now, at this point, the Lambda function, so here's Lambda function. Let me just bring that up in a second. At this point, the Lambda function, if we go into configuration and we go into permissions, at this point, the Lambda function, and this is the role that it's using to talk to other services. Currently, it's only talking to CloudWatch. Okay. We need to give it some more permissions, because now what we want to do is we want Lambda to talk to Textract. Okay, we want Lambda to tell Textract, there is this file you need to extract. We also want it to be able to use that SNS service, and we also want it to be able to read the actual file from S3. Currently, what's happening is S3 is triggering and sending out that notification to Lambda, but Lambda isn't going back to retrieve the file and tell Textract what that file is, right? So we need to add some more permissions. So I'm going to add some broad permissions for the purposes of this lab. But in real world, you would also try to ensure that you minimize what it is that the permissions can actually do. So here we're going to give Textract. We're going to give it permissions to access Textract, so giving it full access to Textract. Also giving it permissions to SNS. So these are all managed existing predefined policies that you can attach to the IAM role. And S3, we'll give S3 read-only access because this particular Lambda function is not actually creating that HTML file to deposit and put it in the S3 bucket. It just needs to read the existing resume.pdf document, right? So there should be a read-only, yep, there it is, read-only access. And we'll add those permissions as well to our role that's associated with the Lambda function that's doing all of that work, okay? Okay, so those are the permissions that are attached to this role that belongs to this Lambda function, which, as you know, currently all it's doing is it's telling you that, hey, S3 triggered me, there's a file up there in S3. Okay, now we also need a role for textract, because if you think about it, textract has to go ahead and pull that file and read that file. So it needs to have access to S3. Okay, it needs to also once it's completed the task, it needs to talk to SNS. So it needs permissions to talk to SNS. So we need some permissions for textract. So for that purpose, I'm actually going to create a brand new role. So if we go to roles, okay, give me a second. Let me just grab a name. Okay, so here, these are my current roles. I'm going to create a brand new role. It's for an AWS service. More specifically, it's for textract to be able to interact with other services. Okay, so we'll add that, and it adds a default set of permissions. And I'm going to call this one textract SNS role. Okay, so that I understand that it's going to talk to SNS at the end of the day, right? And then I'll create this role. Now, this particular role is going to be able or needs to be able to read that file in S3. So Lambda needs to obviously see the file in S3 and tell textract, this is the file. Textract needs to grab the file and also then complete the extraction and then send a notification to SNS. Hopefully you're beginning to realize that roles are becoming really, really important, okay, and how you define them. And one of the typical reasons why there's a lot of bugs and errors and we end up doing a lot of troubleshooting is because we got our IAM roles wrong somewhere. Okay, so we've created the text to extract role, and I'm just going to quickly search for it. There it is. And what I'm going to do is I'm going to add some additional permissions. So firstly, I'm going to add the S3 read access, so you can read the files from S3, that PDF document. Let's just go give it read-only access for now. Okay, can add that. And I'm also going to add an inline policy, a more restricted policy so that it only talks to one specific SNS topic. And I'll just bring up what the policy looks like. Give me a second. Phase 3. I'll bring that up in my Visual Studio Code so you can see it. Okay, so there it is. Okay, so this is the policy. Obviously, this is not the actual SNS topic. This is a policy where I'm saying textract is allowed to push to that specific SNS topic that I just created. So I'll go into the textract SNS. There's the ARN of that particular topic. And here, I'm going to go ahead and paste that in there. Okay, so now textract has permissions to send a notification to SNS topic to say I've completed the extraction. Okay, so I'm going to grab that policy file. And what I'm going to do is go back to the role. So this is the textract SNS role. Okay, and I'm going to add something called an inline policy. And an inline policy basically means that this policy is only for this particular resource. Okay, you can't use it anywhere else. And that's fine because that's what we want. So I'm going to click next. And then obviously I need to give it a name, so a policy name. So what I'll do is I'll just give it the same name as well. I'll not call it role, obviously. I'll call it policy. Okay, and create the policy. Okay, so currently textract, we've created a role for textract to consume. It's going to give it access to read the S3 bucket and pull that file. It's going to then give it access, the ability to push a notification out to the SNS topic, specifically this topic. So just want to make sure that it is the right topic. Okay, yeah, that looks right. And we should be good over there. Okay. Right. So at this point in time, we're in a situation where now we can update that Lambda function. So previously in phase 2, all we could do was we could see that S3 triggered Lambda, and you saw that in the CloudWatch logs, right? Now what we want to do is we want to see how S3 triggered Lambda and Lambda triggered Textract. Okay, so I have another Lambda code, and we're going to update the existing Lambda code. Let me just bring that up in a VS Code. Okay, and I'll just quickly run through what it's doing as well. Okay. So here, what we are doing is we're calling the Textract client, okay? And we need to obviously then provide Lambda with what is the SNS topic and what is the Textract role that Textract is allowed to use. So we actually need to update this. Once it has the SNS ARN and the Textract role ARN to consume, it's going to go through the file. It's actually going to first take a look at what file it is, and it's also checking whether the file has a PDF extension. So if it doesn't have a PDF extension, we're not going to work with that document. This is a way of ensuring that only legitimate, acceptable uploads are going to be used. So if someone uploaded an image or a video, well, we're not going to use that, right? So we can use these sort of methods to try and restrict exactly what happens. It's going to get the key meaning the name, the actual file name, and pass it over to Textract. And it's going to then get Textract to actually perform the document start document text detection. Okay, so it's going to run through and actually read that data. And then once it's completed the job, once it started the job, it's going to hand it over to Textract. So it's going to say Textract job started. So that's all it's doing. Okay. So what I need to do here is just update these. So I need to update the SNS topic ARN. So this is the SNS topic. Update the Amazon resource name for that specific topic. And I also need to provide it with the role that it can use, right? So we've got, let's get rid of this. So this is the Textract SNS role. That's the role ARN. Again, you're beginning to see, hopefully, how important these ARNs are. Paste that in there. I'm going to copy all of that, right? So let's just copy all of that and go back to my Lambda function. I'm going to go into the code, and I'm going to replace this code. Okay. So what we are doing is which is the SNS topic, which is the Textract role. We're looking at the file, and we're basically handing over to Textract to extract the actual data from that PDF document. And then once it's done it, this Lambda function is just going to say, Textract job started, here's a job ID, my job is done. Okay, so it hands it over to Textract. So we need to deploy this. Okay, so that's just deploying now. Okay, so successfully updated the function. So what we could do here now is we should be able to go back into our resume.doc or resume.pdf, and we should be able to re-upload this particular resume. So I'm going to click upload again and just grab the file. Bear with me 1 second. Dump it in there and click upload. Okay, so that has uploaded the file. Okay, just give me a second. Oops. Right, that has uploaded the file. Okay, so what we should do, if we now go to CloudWatch, and if I go to log management, okay, right, if we go back to that resume processor, we'll see there's another entry, another log stream that's created. And in this log stream, you will see what it's doing. So it's picked up the file. So this was the file that was uploaded, and it's handed it over to Textract, and it gives you a Textract job ID. Okay, this is the first Lambda function. Its job is only get triggered because I uploaded a file in S3, hand over to Textract and tell Textract, here's the file, go extract it. That's all it's doing. Okay, so that was phase 3. So the next phase is we now want to see what exactly Textract did. Was it successful in actually extracting the file, right? And remember, Textract is sending a notification out to SNS. So we can use that notification to allow a subsequent Lambda function to be triggered to read the data to be able to see what got extracted. Okay, so we'll do that next. So, right, so we'll create the next function, the function that's even further along that workflow. Okay, so I'm going to go back to functions. Okay, and let's get rid of that and create another function. And this function is going to be called something sensible like Textract result processor. Again, these codes are written in Python, again, available in our GitHub repo. So feel free to run them in your own AWS account and actually, get some hands-on. And we'll scroll down and click create function. Okay. Now, the reason why we're doing it this way, why aren't we just using the first function to, get the extraction, is because we're not sure how long it's going to take Textract to complete the job. Okay, if you think we're extracting a massive book, it could take a good 10 minutes. Okay, and that's the other thing to be aware of. Lambda has a timeout limit of 15 minutes. Okay, so if a particular piece of processing that gets done, if it's going to take longer than 15 minutes, then maybe you need to be using ECS or something else. Also, Textract, we can leave Textract to carry out the task and then subsequently notify a downstream Lambda function. Okay. So here, what I'm doing is I'm creating a new function called Textract result processor, and just say accept to that. Okay. And I'm going to make some modifications to the actual setting for this. So firstly, Textract does the extraction, sends a notification to SNS. SNS needs to send that on to something, i.e. this particular Lambda function. So we're going to create a trigger first. So the trigger is this Lambda function is going to be triggered by SNS. And specifically this SNS topic, Textract complete, that we just created moments ago. So we'll add that. Okay, so you can see that's the trigger that's triggering the Lambda function. Okay, in addition to that, this Lambda function needs to be able to talk to Textract or receive that extracted data from Textract. So we're back to the old IAM roles again. Okay, so I'm going to go into configuration, and also it might take some time to process that data. So I'm just going to increase this. I'm just going to set it to 5 minutes. You probably don't need 5 minutes, but I'm just going to set the timeout high. Okay, and I'm going to also set the permissions. So here's where you set the permissions. This is the role that this particular function is using. I'm going to update it with the ability to talk to Textract. Okay, so specifically we'll add permissions, attach policy, and I'm going to say Textract and go Textract full access. That should do it. Okay, so it's got permissions to receive the data from Textract, and as well as its basic permission so that it can send notifications to CloudWatch. Right. Now what we're trying to do in phase 4 is we're trying to see the extracted data, okay? And you can visualize exactly what's happening then. So let me bring up the Lambda function code for this Lambda function. Give me 1 second. So we're there, and I'll bring that up in the IDE as well and show you. Okay, so this is also using obviously the Textract client. SNS event received. Okay, so that tells us, okay, it's got the SNS event. So this is just for our benefit, but ultimately it will get the job ID and the status message. And what it's going to do is it's going to go through a loop where if there was a lot of data in that resume.pdf document, it will paginate through it. Okay, so it'll go through it so that it extracts all of the data until there's no more data left in that extraction. Okay, so that's where this particular function currently operates. So I'm going to copy all of that, go into the textract, the textract result processor function. I'm going to add that code in there. So this is the code this Lambda function is going to use so that we can see the extracted data. Okay, so we get rid of that and paste that code in there. Okay, so let's just bring this down. Okay. And then I'm just going to deploy that. Okay, so that's getting deployed, successfully updated the function. Okay, brilliant. So we can go through that test now. Let's take a look at uploading the resume file again. Okay, upload the resume file, and I'll click upload. Okay, so the file has now been uploaded, right? And we can now, so what should have happened is the first Lambda function should have run and triggered, oh, a new file got uploaded. Hands over to textract, here's the file, go do the extraction. Textract does the extraction, completes it, sends a notification to SNS. SNS triggers the second Lambda function to see what that data is. So if we go to CloudWatch, and if we go in here, you'll see there's a brand new logs group created. So the first log group, which was for the first function, okay, that basically says, I handed over the job to textract, here's the job ID. And if we go to the textract result processor function, I can see the entire extract of what was in that PDF document. Okay, so we started off, these are the records. Okay, again, you know, SNS event received. Where did it come from? Which ARN was used? All of that stuff. It succeeded. And this is the final extracted text. So from that PDF document, we've got the data. Textract was able to extract the data, and all of the stuff is there. Okay, so previous experience, education, skills, page 2, page 3, so on and so forth, right? So we are in a good position now. We're in a place where our workflow is operating as expected. Our second Lambda function is able to see and be notified of that extracted data and even read that extracted data. So what it can do now is it can go and talk to Bedrock. It can tell Bedrock, look, I've got this data, make it into a format that I can really use. Okay. So let's move on to phase 5, which is where we're going to work with Bedrock. Okay, so I'm going to open up Bedrock next. Okay. If you're using Bedrock for the first time, you may need to enable it, but that shouldn't be the case anymore because that's changed. But essentially, when you go into Bedrock, and especially if you've got your free plan account, you would have done one of the tasks that gives you that $20. So remember, if you create a free plan account, you can get $200 worth of credits from AWS. At sign up, it only gives you $100. You need to complete 5 tasks. One of those tasks is to play around with Bedrock. It literally walks you through it. It's very easy, and you got your $20 for it as well. Okay. So, and again, if you need instructions on how to do that and you want to walk through, it's on our YouTube channel. You can see the full step-by-step guide. Okay, so here what we're going to do is we're going to be using Bedrock to actually convert that raw data into a JSON format so that our Lambda function can read and understand and create our HTML document from it. And remember, I had uploaded the PDF document into the dark folder. So it's going to create the dark mode. And I'll show you the code for that as well. Okay. And you'll see how that works. Now, what are the things that you have to create when you're working with applications that you're building? So you need to create something called an inference profile. So I'll show you what that is. So basically, it defines the model that you're going to use and the regions in which to route your inference requests. So we spoke about inferences yesterday. And so we need to create something called an application inference profile so that we know exactly which model we're going to consume, which regions we're going to consume it in, etc. So I'm going to create that first. I'm going to give it a name. We'll just call this one something like that. Okay. And the model that I'm going to work with to create that JSON extraction, to convert that raw data into JSON, is going to be Anthropic. And I just play around with Sonnet 4.6 a lot, just out of habit. And you can try any of the other models as well. It should work because we're just creating a JSON extraction, right? A JSON conversion. So create application instance profile. I need to give it a name, or rather a tag. And I'll call this one Jesh. Let's something like that. Very easy. And create my inference profile. Okay, so my inference profile, specifically this ARN, this is what I need to reference from my application code. Okay, now the first Lambda function, remember what it does. It just gets notified a new file has been uploaded, tells text extract, here's the file, text extract extracts the file, and then sends an SNS to the second Lambda function. This second Lambda function, the text extract result processor, a bit of a mouthful, has to have the necessary permissions to now talk to Bedrock. Remember, it was able to talk to all of the other services, but we've not configured Bedrock access yet, right? So we need to give it yet more permissions. Okay, so I'm going to go into configuration, go down to permissions, open up that particular role and update that role. Okay, so we're going to give it, so it's got the text extract full access, but also it now needs to talk to Bedrock. Okay, so I'm going to give it Bedrock access as well. So Bedrock full access. Okay, and this Lambda function is going to also end up, once it gets the JSON, create that HTML document and put it into the S3 bucket. So now it's not just reading from the S3 bucket, it also needs to add data. It needs to create an object in the S3 bucket. So we need to give it some more permissions for S3. We need to give it the ability to write back to S3. Okay, so for the sake of simplicity, I'm just going to do S3 full access. Okay, S3 full access. But obviously, you could create a custom policy with a custom, you could use a custom policy that looks at that specific bucket. Okay, so you can do that as well. Okay, so that policy has been attached to the role. Right, and we've created our inference profile as well, which is on Claude Sonnet, etc. So the next thing that we need to do is we now need to update the Lambda code so that now it can not only look at the extracted data, but also send it to Bedrock, get the JSON back from Bedrock, convert it into HTML, and then upload it to S3. Okay, so let me bring up the code for that. Just give me a second. Okay. Okay, so here it is. Okay, so this is the Lambda code. It's using a client for text extract, it's using a client for Bedrock, and a client for S3. Okay, and we need to provide it with the bucket name. So my bucket name this time is this one over here, Rajesh resume website. Which bucket is it actually going to work with? Which bucket do we want to put the configured website into? Okay. Let's just do that. And also the actual inference profile, so the Bedrock inference profile that we're using. So here, if we take a look at, this was the resume HTML Gen AI inference profile. So I'm just going to grab that and upload that as well. Okay, so let's just delete that and do it again, sorry. Okay, so make sure I get the right one. Copy and paste it in there. Okay, so that's the inference profile added. So what does this Lambda function actually do? So it's doing the same thing. It's receiving that SNS event. It is then looking at the key or the file name. Remember in S3, there's no such thing as folders. It's all delimiters and prefixes, and they become part of the name. So it's going to look at it and see if in the key there is modern, then it's going to use the modern style. If it's dark, it's going to use the dark style. If it's minimal, otherwise it's going to use the minimal style. It's going to extract the data as previously, run through any pagination and get all of the data extracted. It's then going to send a prompt to Bedrock. It's going to say, extract structured resume data, return only valid JSON, and provide these headings with the JSON. So name, summary, LinkedIn URL, key achievements, experience, title, company, start date, end date, responsibilities, and so on and so forth, till it gets down to skills. It also provides some rules. Use all information from the resume, extract key achievements as a separate array, extract the LinkedIn profile URL if present, do not merge achievements into summary. So these are some, guardrails for it as well. Do not omit anything and do not invent anything. Okay, so let's avoid any hallucinations as well. And produce the full text of it. Okay, we're then specifying some parameters. Okay, so so we're using Anthropic. The maximum tokens, we're allocating 3,000 tokens. We've got our user and content. Okay, so user prompt earlier, and then obviously the content. And then what we're doing further down is then once we've got that data, we're formatting the data into HTML and CSS styling. So we're going through all of that, okay? And we're basically seeing the JSON structure and depositing all of those individual pieces of information in the relevant bodies, okay? So that's going to go all the way down, right? Until we get to the bottom where once it's done this task, it's going to proceed with actually saving it back to S3 and specifically into a folder called website user1 and index.html. And this user1 is obviously adjustable based on who logged in at the time of creating the account, because there will be a folder created for that user. And so it'll pick that up as well. Okay, so we can do that as well. So I'm going to copy all of that and literally go into my function. So give me a second over here. And go into the code. And let's come down here. And this is the text processor function. So I'm going to copy all of the, highlight all of this and delete and paste that in there. Okay, so we're basically just to recheck a couple of things. Want to make sure that we're using the right output bucket. So Rajesh resume site. Yeah, okay, that's fine. And obviously this inference policy 7R3V. 7R3V. Yeah, okay, so that should be fine. And then we can deploy. Okay, so that successfully updated the function texttract results policy, results processor. And if I take a look at the configuration and go to configuration, that's set to 5 minutes. I've got the permissions in place as well that I need. Okay, so just take a look at the roles. Okay, so I should be able to talk to Bedrock, texttract, and S3. Okay, so now what I can do is if I go back to this folder, user folder, and if I upload this resume, give me a second. Okay, so then I can go ahead and upload the file. Okay, so what should be happening now is the first Lambda function should see it, inform texttrack extracts the text, sends it to SNS. SNS then speaks to sends it to the second Lambda function, speaks to Bedrock, gets the JSON format, and converts it into an HTML format. So if we go to the Lambda function again, if we go to CloudWatch and take a look at the resume processor, so here we should be able to see that okay, yep. So it's gone and it's done the texttrack job started and it's got the job ID, and essentially that should be fine. So if we go back to the other log stream, the results log stream, okay. So what it's now telling you is that if we go back up here, that it got the SNS event, it basically got the job that for the extraction, so that was all fine. It then proceeded to actually check the file name. So it saw that the file name contained the dark in it, the dark folder, and then it said text ready for Bedrock. It then sent the entire data set to Bedrock and got back the structured data format. Okay, so it got that structured data format, it generated the HTML and uploaded the HTML to S3. So what we should be saying is that if I go to S3, and if I go to the resume site, and if I go to, and that loads up, website, there should be a folder in there called user1. And in user1, there should be a file called index.html. Okay, so it's generated that index.html. And so technically what should happen now is I can take this distribution point, paste that in there, and go website, to user1, index.html, and there's our website. Okay, so this was a plain, boring one, right? And we used all of our tools and services. We used texttrack to extract the data. We used Bedrock to help us out as well. Okay, and if we take a look at what we generated, was this website that looks a lot prettier. It's laid out correctly. It's a fully generated solution. It's used Bedrock to understand the context so that it knows exactly where to put the data, the extracted data in. You've got summary, you've got achievements, experience, education, skills, and a link to your LinkedIn profile as well. Okay, and obviously you can update the Python code to do more fancy things. Make sure you've got an image, contact details, and everything else in between that you need for a typical resume website. Okay. All right. So I'm just going to let that land with you for a couple of seconds, and just hopefully you can see just how this actually works. Okay. And are able to look at the way how we've been able to use this application. From a user perspective, all he did or she did was sign up, upload, and outcomes. Selected a format. So in this case, maybe the user wanted the dark mode format, and then out comes the solution, right? And in behind the scenes, there's Lambda, there's IAM roles, there's S3, there is texttrack, there's Bedrock, there's more Lambda, and then finally you get your website. So as a cloud engineer, as a solutions architect, your job is to be able to understand the intricacies of all of these individual components and how you would use them to structure your solution. Okay. All right. Any questions? Any questions at all? Okay. When you say allocating 3,000 tokens, what does that mean? So basically, tokens are, the maximum number of words that you're going to allow to upload or download, right? So tokens are broken down in tokens are your actual text that's broken down into smaller chunks. So a token could be a word, it could be part of a word, it could be the ending of a word. Depending on which model you're using, tokens are handled differently. But obviously, you can adjust that based on what you require. So does it mean that really 300 tokens are uploaded from PDF content or something else? Exactly. So you want to make sure that you are using or giving enough tokens to be able to work with. If you're using a large book, that you're extracting, then obviously, and you're converting or you're analyzing, you're going to need more tokens for that. Okay. All right. Okay, so hopefully you found this demonstration and live useful. Hopefully you will see exactly the intricacies of all of the different components that go to build a solution. And when you're building a solution for a client, a customer, or if you're working for a company that's built solutions, you can see just how detailed you need to be in your planning. You need to consider things like security. So we're using CloudFront. We're using CloudFront so that we can protect our website. Our website is displayed on standard HTTPS, okay? And obviously we can add custom domain names in front of it, which means that the traffic is encrypted. There were several settings that we need to configure or we should configure in the real world, like SNS. Are we encrypting that communication between SNS and Lambda? There is also things like with CloudFront, you've got WAF and you've got various other security measures in place. The bucket itself still has the block public settings enabled. Okay, so if I go to the bucket in question, it's not directly exposed out onto the internet. That's still on. It's sitting behind CloudFront. CloudFront is doing the proxying. Okay. And then obviously in the back end, within the AWS ecosystem, you've got TextRack having all of the necessary permissions to talk to S3 and then subsequently send out notification to SNS. And the Lambda function that picks up from SNS has permissions to talk to Bedrock, and those can be drilled down and made more granular so that you follow the principle of least privilege. So why the second Lambda needs access? Because it needs to be able to receive that notification. Okay. But yeah, I mean, I've just kept broader permissions, but you can narrow that down further and ensure that you only allow specific permissions to go through. Okay. Right. Any other questions? Any other questions at all? Okay. When creating a SaaS, how best can one calculate pricing for clients, especially with tokens involved? To be honest, this is something you're going to have to run through a lot of benchmark testing yourself. Okay. So when you're trying to calculate pricing, you obviously can use, you'll need to run through a lot of testing yourself and see how much tokens are being used and the particular solution that you're building. So if we're talking about this resume website, you want, obviously, you will have a rough idea once you've started to build a solution and see what the consumption is, because different models will use tokens in different ways because they create and chunk the text slightly ever so differently in terms of creating those tokens. you will have to run through various tests to see how much is being consumed. And a typical resume, therefore, in the case of this particular application, usually would span, 1 to 4, 5 pages. And so then you would run various tests for that in order to identify, what that pricing is. It looks like what the cost to you is. The cost also comes from things like, the storage cost in S3, um, what your anticipated rate of requests are going to be within that website. Okay. The Lambda function costs as well as the Lambda function is being triggered. Usually in this example, when I create a resume, I might create 3 or 4 variants of it, but I necessarily won't be triggering the Lambda functions, every day and generating a new resume website every day, right? So you're going to have to run through those tests manually and just figure and work that out based on the pricing model. Then you can also use the pricing calculator on AWS to help you work out what the cost is to you. And obviously, then you can work out what you would charge the clients. Yeah. Okay. Any other questions? Cool. Awesome. Okay. So this is pretty much it. I hope you really had a good 5 days over this session. Okay. I'm just gonna, okay. And so that was the live demo. So hopefully you found this really useful. And over the last 5 days, you're now even more curious to try and, you know, proceed further along and actually understand and start developing. There's another question, just bear with me. Architecture used to send email notifications when an alarm is triggered. Bedrock can be used for formatting that email. How about cost involved? Yeah, exactly. So every time you're using Bedrock to, do something, you are actually consuming and making API calls to Bedrock. And then depending on, the model that you're using, you're going to have to work out the costs involved in that. So that's based on the number of tokens that you end up consuming as well. So it depends on email size, the frequency, all of those aspects come into play, Abhijit. Okay, so hopefully you found this useful. Thank you so much for obviously taking the time to spend these 5 days with me. If you've been with all throughout the 5 days, and for your investment in this, and hopefully you being able to see just how intricate and detailed all of this stuff is. I do want to obviously highlight about my accelerator program, and it's something that you might want to consider taking on. So if you are curious, I mean, if you've had a good foundational insight into how this all works and this has been good for you this week, then I'm ever so glad and happy that you have been able to benefit from the 5 days that you've spent with me. If you are interested, however, in taking this forward and you want to actually, you know, um, get certified as well as start building solutions and hopefully work towards a job role or upskilling into uh, you know, AWS and cloud technologies as a cloud engineer, as a cloud architect, AI engineer, whatever the role is you're ultimately seeking, that foundational skill set is really, really important. Understanding the intricacies of building architecture, being in a position to use all of the tools efficiently, securely, and reliably, and then also thinking about observability and support and ongoing maintenance are all part of the solutions architect program that AWS offers you. Um, so here, what I'm offering is an accelerator program. You've got standard courses that you can take. Lots of providers are out there. You've got video courses that you can take where the onus is on you to complete those video courses and ultimately, complete them. And most video courses are going to be, you just working towards the exam. You got a lot of live courses, live instructor-led courses as well by various organizations. And usually what happens is they're either going to be standard run-of-the-mill 3-day courses. So you're learning everything in 3 days, especially with official curriculum, or you are spending with third-party companies that are, spreading that out over 5 or 7 days, which is fantastic, gets you prepared for the exam. But the accelerator program, especially the standard one that I'm proposing and that I'm offering, is a 25-day live cohort. Okay, the next one starts 15th of June. And essentially what you get here is a blended learning approach. Basically, what's involved in it is the entire course syllabus and course content available to you as video content. But I spend with you 25 days, 2 hours a day, Monday to Friday, to go through all of that content to prepare you for the exam, as well as give you hands-on practical skill development across 4 capstone projects. So these are not just normal tutorial labs. These are end-to-end solutions that you build live in your free plan account and are able to also work with the troubleshooting and the bugs that you go along as you're building out the solution, because it's not going to work. It's not just a tutorial where you go step by step and it gets done and I've done the project. You actually get to experience when things fail and how you would go about troubleshooting and fixing those things just as you do in the real world. So the standard accelerator program, 25 days, you get the full on-demand course, yours to keep, but you also get those 4 capstone projects. I spend those 2 hours with you every day, not just reiterating what's in the course syllabus, but also looking at more important elements like the architecture patterns, the reliability, cost efficiency, and performance elements of it, and more importantly, best practices. Also with the accelerator program, you'll also get free practice exam simulators so that you can prepare for the exam. And every live session is also recorded separately in addition to the video courses. So this blended learning approach gives you an opportunity to spend those days learning the material for the exam, but also spend time with me where we're looking at real architecture designs, where we are troubleshooting stuff and where we are fixing things so that you are getting some real world hands-on experience. The VIP program extends that for a further 6 months. So in that program, as well as all of the stuff that you have learned in the accelerator program and prepared yourself or done all of the materials for the exam, you'll be spending 13 sessions with me over those 6 months, where we'll first work on clearing the exam. Okay, so I'll work with you to actually help you clear the exam in terms of preparing and doing a lot of revision. And we'll be spending 3 sessions specifically. You'll book the exam, you'll sit the exam, and if you've done everything right, then you're in a good place to actually complete and pass the exam. But then subsequent to that, we're going to have one-to-one mentoring sessions where I will help you with things like resume build out, LinkedIn rewrites, mock interviews. So if you're getting any job interviews, we can go through a mock session where I will be able to support you and guide you in the best ways to, answer those questions and look at the job description and see what are going to be important in that interview that you're taking. I'll help you build a career roadmap as well over the course of that 6 months and what other courses you might want to take. But more importantly, and this is what I want to really highlight, is that you're going to have an opportunity to simulate being a real architect yourself. So we're going to do a live role play session. I'm going to give you some problems, a couple of 2 or 3 business problems to select from. You're going to be in a position to design, draft, plan, and implement a solution. It's going to be where you're going to conduct things like requirements gathering. You're going to conduct things like stakeholder management. You're going to be looking at how to make your proposals for a given solution that you're coming up for that specific problem. And you're going to get pushback on it. So you're going to be able to see how it works in the real world. And if the problem or the solution that you're proposing is approved, you'll implement that solution. The deliverable from that is also going to be a podcast that you and I can do if you're up for it, where it's going to be recorded, and then you can use that as an asset in order to promote yourself on your LinkedIn, on your GitHub pages, and even if you want to, on your own YouTube as well. Okay, so this is the additional elements of that VIP for the AWS Accelerator. I am limiting that to only 10 because I'm going to spend time with you as well and work with you to try and either you're looking to secure a new job, or you're trying to upskill, or you're trying to get that promotion, or you're trying to basically get into a specific role. I'm going to work with you throughout those 6 months. Okay, so I'm leaving that on the screen. If there are any other questions, then please feel free to put them into the Q&A. Any exam vouchers available? So we don't give exam vouchers. but you will get a free practice exam simulator for a very top exam simulation so that you're well prepared for the actual exam. This is for Sri William Sai. Okay. Yeah. So just so you're aware, the exam, if you go out to take the exam and finally take the exam AWS charges $150 for the solutions architect exam. But like I said, with my course, you'll be well prepared for it. With the free exam simulator, you'll have a lot of questions to actually be able to get through the exam. My focus is not just trying to get you through the exam. I want you to be in a position where you're really confident in that interview so that you can articulate different architecture patterns, be able to defend the architecture designs that you are suggesting and proposing, and be really confident in a way so that you're able to demonstrate that you have got hands-on experience with cloud computing and specifically with AWS technologies, and then hopefully secure a role with the company that you're having your interviews with. Okay. Any other questions? Just give me 1 second. Love the demo. Thanks, Venu. So basically, you can click on the QR codes, and that will take you directly to where you can see all of the pricing. You've also got the link over here, isacademy.com/p/AWS-accelerator. All of the course content, all of the syllabus is available on the website as well, so you can see exactly the breakdown. And in fact, what I'll do is I'll drop. Give me a second. I'll drop some details in the chat as well. Okay, let me just put this in the chat. Second. So put this in the chat. And I'll put this in the YouTube Live. I've got a question on YouTube Live. Bear with me 1 second. Oops. No. Okay, so I've just put the link in the chat as well on the YouTube Live and in the normal Zoom chat. Just say, I have another question. I currently practice Google Cloud. I have another question. I currently practice Google Cloud. Which one is the best exam, AWS or Google Cloud? So that's a very subjective question. But if you think about it, if you currently are you currently working as an employee for a company that is using Google Cloud Sri? So this is Sri William Sai. Are you currently working in Google Cloud for a company, or are you just practicing and learning? Okay, personally learn. Okay, yeah. So I mean, it's great that you're actually learning Google Cloud because what it means is that you can easily transition to AWS. AWS is the leading cloud provider, and it really depends at the end of the day, where you're applying for your jobs. You're going to find that a lot of companies are using a combination, in fact. So if you decide to shift over to AWS, the first thing is you're going to get a lot more companies that are using AWS because they are the leading cloud provider. But also it's going to be a bit easier because you've got some experience with Google Cloud. It's going to be easier to transition to AWS should you choose to do that. Okay. Yeah. Any other questions? Okay. Yep, sure. Anytime, Sri. Okay. Okay, just looking at if there are any other questions. Okay. So as I said, you've got two different plans here. You've got Accelerator and VIP. Sorry, Accelerator Standard and VIP. And really, it's a decision on, how you want to go about this. Obviously, with the VIP, you've got a lot of hand-holding and support across not just getting ready for the exam, but you be the architect role play is going to be really, really beneficial for you. It's going to give you that opportunity to experience how it is in the real world. And that gives you the confidence to perform really well in interviews and support your knowledge and skill sets. The cohort starts 15th of June, so you've got 2 weeks to have think about it. Any questions at all, you want to even discuss this with me on a one-to-one basis, just connect with me on LinkedIn and I can set up some time on the calendar and we can have a quick chat over Zoom or something. So not a problem there at all. Okay. If there are any other questions. Okay, if there are no other questions, then we'll call it the end of the day. I want to take this opportunity to really thank you for investing this week with me. Time is precious, and I totally hope that you were in a position to gain some good insights in the way how solutions in the cloud are being built. And if you're new to this area, definitely have developed some curiosity to see whether or not this is the way for you. Okay, but otherwise, I bid you farewell and I wish you the very best. You have a great weekend ahead. If you need anything else, you know where to catch me. There's a Q question. Bear with me 1 second. Yeah, absolutely. Thanks, Vinayak. You're welcome. If there's anything else, you reach me out on LinkedIn.